Are you looking to begin your cloud architect or cloud engineering career? If so, this video is for you. Hi, my name is Michael Gibbs and I'm the founder and CEO of Go Cloud Architects, and we're an organization dedicated towards building high-performance cloud computing and networking careers. I've been working in technology for over 25 years now, and I've been coaching or mentoring others to get their first tech job or get promoted in tech for over 2 decades now, and I absolutely love doing that. Today we're going to be talking about some cloud architect fundamentals. Specifically, we're going to be talking about containers. Now, if you're new to containers versus virtual machines, please see the previous video for which we talked about virtual machines and containers. I'll leave the link in the description below. In this video, we're going to dive just a little bit deeper into containers, and knowledge of containers, which are one of the 2 primary computing platforms on the cloud, is an absolutely critical cloud architect skill. So let's talk about containers. What is a container? A container is a very lightweight, modern form of virtualization. Effectively, containers work as follows. Basically, you have your host with its operating system installed. You've got some type of a container engine, and then basically you have these logically separated applications that are completely secure and logically separated from each other. And basically what happens is inside the container, you basically have the operating system, any critical dependencies that it needs, and that's it. And you can take this container and you can move it to another system or another cloud provider. So this technology is really vendor agnostic. You make a Linux container, it can work on a Linux system. And you could take that with you from your data center to a new data center, to AWS, back to your data center, to Azure, back to your data center, to GCP, or you can keep them on all the data centers or all the clouds all at the same time. So containers are lightweight and they're very versatile and they're very standards based, which makes it fantastic for cloud computing. Now let's talk about what is Kubernetes. So when we're talking about containers, you've got multiple ways to do this, but we're going to talk about containers because that's the enterprise-wide container management strategy. So Kubernetes, which some people call as K8s, is really an open source system for automating the deployment, the scaling, and the management of containerized applications. And this is an industry standard and it's used everywhere. Think of it this way. At a high level, Kubernetes and the containerized applications are going to work this way. The applications and their dependencies are put into a standardized image, and the image is then placed into a container, which could be placed upon a fleet of computing instances, maybe a bunch of virtual machines, maybe a bunch of physical servers, anywhere you want to put them. So that's what's going on with Kubernetes. You've got your applications, you pack it up, and you can move these applications for the most part wherever they need to be. So why do organizations use containers? Well, first, it makes your workloads very portable, and because these containers scale easily. And Kubernetes is widely used to go to the cloud and back. It's also used with machine learning applications, AI applications. Realistically speaking, it just simplifies your deployment so much because you can very quickly deploy and manage many microservice-based applications very simply. And most importantly, I'm going to say it again, it's provider agnostic, which means you can use it with any cloud you want, and your data center, you can move on and off clouds very simply. So this is your chance to go to the cloud. This is a highly efficient service, and you can try things. And if it doesn't work, you can just move back so easily or move to a new cloud because these things are very portable. So portable, efficient, and lower cost than virtual machines. This is just great technology. What is Kubernetes actually doing? Well, for the most part, it's providing an orchestration of your container services. So look at it this way. It enables you to basically automatically mount a storage system of your choice, whether it be a local store, a public cloud provider, etc. Then it enables you to roll out and roll back new applications that are containerized very quickly. Basically, you can describe the state of the container for your desired deployment, and basically speaking, when you do that with Kubernetes, and you can change it to the actual state at a controlled rate. So you can figure out your desired state and then move it over and do it in a controlled way to improve your deployments, the accuracy of deployments. So this is really great. So for example, you can automate Kubernetes to basically create a new container for deployment, remove existing containers, and adopt all the resources to the new container when it's appropriate. So this is kind of great. So let's talk about some other features that you get with Kubernetes, which is why organizations love this. you get something called automatic bin packing. And basically you provide Kubernetes with a cluster of nodes that it can use to run these containerized tasks. You tell Kubernetes, how much CPU, how much memory in terms of RAM each container needs. And Kubernetes can then fit the containers to your nodes where you have the compute capacity to run these nodes. So it makes great use of your resources. And you know what? It's also self-healing. So Kubernetes is able to look at a container that's going to fail, and it's going to be able to replace the containers or kill any of the processes or any of the containers that don't pass a health check. So then you can basically have a new one come up that's healthy. So really fantastic way to modularize your services, decouple your services, and give them almost unlimited scalability. So that's why we like this. So let's talk about how Kubernetes works. Well, like anything, you're going to have a control plane and a data plane. So let's talk about what happens at the control plane or the orchestration level. So Kubernetes is running this control plane software, which typically runs on multiple master nodes. You've got high availability. So something's got to control the situation. You've got multiple master nodes. And then the control plane basically will make decisions which clusters are going to do the workload. It's going to schedule it. It's going to maintain the target, manage the target state of the cluster. So you've got something that's watching all of your resources, and it's going to deploy the resources to places that are healthy. So keep that in mind. We've got a lot of things that are part of this control plane. We're going to talk about a few of them. We're going to talk about the Kube API server. Now this API server is really the front end of the control plane. This is which exposes your Kubernetes API in a REST API format. This is going to consume, the YAML templates or the JSON input. So let's talk about some more things that goes on. We'll talk about the cluster store. So this is realistically basically a database. It's a key value store that maintains the information of the cluster. It persists the cluster state and your configurations. So you're also going to have something called the Kube Manager, and inside of your control plane, there's basically going to be several controllers, such as a node controller, a job controller, a deployment controller. As the name simply suggests, the Kube controller manages all the containers. So you might want to call it the controller of the controllers. And the last part we'll talk about from the control plane perspective is the Kube scheduler, which realistically actively listens to the API server for new worker tasks. And then it's going to assign a worker node to complete the worker task after it found one, because remember, it's listening for new tasks. Now you know how the control plane works. Now, the control plane is doing the orchestration, but the data plane is where the computing is actually done. So where is this going to be? This is going to be done on your worker nodes. So basically speaking, you're going to have worker nodes that are going to do the work. And the worker nodes are going to have components which basically maintain the running pods and provide the Kubernetes runtime environment. So your worker nodes are where the work's going to be done. And basically what's going to happen is these running pods are an encapsulation of containers. So more often there is only one container running in a pod, but it's possible to have multiple containers running in a pod. Part of your data plane is going to be this kubelet service, and kubelet is the main Kubernetes agent running on each node. It's what registered nodes with the control plane and listens for the API server for a work task. So, after that happens, it's going to create and execute a pod, and once that's done, it's going to report back to the control plane. So you've got the data plane doing the work and reporting back to the control plane. So basically, it's like a manager and agent environment that you should understand. Let's talk about the Kube proxy. And the Kube proxy, realistically speaking, is a network proxy that you have running on each node. It controls the communication between the pods via the pod's IP address from network sessions inside and outside of the cluster. And realistically speaking, the container runtime is really the software that is responsible for the containers. So what did we talk about? Organizations love Kubernetes. Kubernetes is an open source container management and orchestration service. It's got two components. It's got a control plane that manages all of your resources and the deployment of your containers. And basically speaking, it has a data plane where all the computing platforms are used. Organizations love it because it's vendor neutral. It works in the data center. It works on all clouds, and it enables application portability, self-healing environments, and basically near unlimited scalability. I hope you've enjoyed this video on Kubernetes services and containers. This is a video in our Cloud Architect Fundamental series, as in something that is absolutely essential knowledge for the cloud architect or the cloud engineer, and realistically speaking, anyone that wants to build a cloud computing career. Thank you so much for watching this video, and I will see you in another video very soon. It was so nice having you join us for this video today. Let me tell you about some free services we do for the cloud community. Twice per week, we have a free How to Get Your First Cloud Architect Job webinar, where we tell you all the things you need to do and know to get your first cloud architect job. In addition to that, once per week, we actually have a free question and answer session live on YouTube, where you can come and ask us any questions you want about building your career related to cloud computing or networking, and we'll answer them in real time for you because we want to get you to your goals. Several more times per week, we have guests from industry experts that I have known for decades that are movers and shakers that have changed the world, that can give you information so you can build the best career. I invite them periodically. They are on my show. If there's a chance to do some free training on our channel, we'll do it live because we want you to all to have the best skills for the best career. So please subscribe and hit the bell. I look forward to seeing you, and I look forward to assisting you in your technology career. Thank you so much. This is Michael Gibbs from Go Cloud Architects.